complex fractions. In this video, we'll simplify complex fractions by clearing the denominators. We're looking at a complex fraction here. It's got a fraction in the numerator and a fraction in the denominator. This kind of complex fraction doesn't have any additions or subtractions within the numerator and denominator. So the easiest way to deal with it is to think of this fraction bar as a divided by sign. The numerator, 2 over y plus 4, is divided by the denominator, 14y over y squared plus 8y plus 16. Well, remember to factor y squared plus 8y plus 16 is a perfect square trinomial, and it factors to y plus 4 times y plus 4. Now we can turn the second fraction around and change divide to multiply. So the first fraction stays the same, and the second fraction is flipped upside down after divide is changed to multiply. So now the y plus 4 times y plus 4 is on top, and 14y is on the bottom, and we can cancel. Y plus 4 cancels with y plus 4, and 2 cancels with 2 times 7, so there's a 7 left behind in the 14. And when we get done simplifying this complex fraction, all that's left is y plus 4 on the top and 7y on the bottom. And so we end up with y plus 4 over 7y. Well, here's a complex fraction, and this one's more difficult to simplify because we see we have an addition in the numerator, an addition of fractions. Well, one method would be just to simplify using the order of operations. So I would add the expressions in the numerator first, and then divide by the denominator. That's a very straightforward method, and it will work. But I can show you a method that's a little bit easier. The second method is to multiply the big numerator and the big denominator by the least common denominator of all the denominators in the problem. If I look at the denominators in the problem, I have v plus 4 and v minus 5. And then there's another v plus 4 in the denominator. So this is the least common denominator of the whole fraction. And I'm going to multiply v plus 4 times v minus 5 times the numerator and v plus 4 times v minus 5 times the denominator. Since v plus 4 times v minus 5 isn't a fraction, I can put it over 1 to make multiplying the fractions more straightforward. As long as I'm multiplying the numerator and denominator of the fraction by the same thing, I'm not changing its value. I'm just simplifying. So I start out by distributing this common denominator to each of the two terms in the numerator. That's so much writing, it's hard to fit on the page. But we see then that we can cancel the v plus 4's for the first term, and we can cancel the v minus 5's for the second term. And so we're just left with 7 times v minus 5. Let's write that down here. 7 times v minus 5 plus 2 times v minus 4. So the numerator now doesn't have any more fractions in it. Let's look at the denominator. When I multiply the denominator, it's little denominator also cancels with the v plus 4, and so the new denominator again is not a fraction. It's 9 times v minus 5. So this step has turned the complex fraction into a regular fraction, which I guess is better. And now we can simplify. 7 times v minus 5 is 7v minus 35. And 2 times v plus 4 is 2v plus 8. Now if I simplify that by adding like terms, I'm going to get 7v and 2v, which gives me 9v, and minus 35 plus 8, which gives me minus 27. And that's over 9 times v minus 5. Well, we can factor a 9 out of that numerator. 9 times v minus 3 is the same as 9v minus 27. And so I have 9 times v minus 3 over 9 times v minus 5, and the 9's cancel. So the final result is v minus 3 over v minus 5. You know you can't cancel those v's. This whole complex fraction simplifies to be this simple expression. Let's try the LCD method on this complex fraction. So I have the number 2, and I'm going to write it as 2 over 1. And I'm subtracting the fraction 2 over y minus 6. Now on the bottom, in the big denominator, I have a 1, which I'll write as 1 over 1, so I have a fraction. And it's subtracting y minus 3 over, and now here's the part I want to rewrite. For y minus 24, I can factor out of 4, and it becomes y minus 6, because 4 times 6 is 24. So if I look at all the denominators in the fraction, I have 1 and y minus 6, 1, 4, and y minus 6. So my common denominator is 4 times y minus 6. And I'm multiplying the top and bottom of the big fraction by the same thing. Now to make the multiplication easier, remember that this is over 1. Now I can distribute 4 times y minus 6 times the first term in the numerator and times the second term in the numerator, and times the first term in the denominator and times the second term in the denominator. Now it's a lot of work to write that all out, but if you're not sure what's going on, it's best to do it. But basically what I have is 2 times 4 times y minus 6. They're both over 1. So I'm going to write that. That's the first term. Now I'm subtracting the second term, and so I'm multiplying 2 times 4 times y minus 6 over y minus 6, and the y minus 6 is here. This one and this one will cancel. So now I'm just subtracting 2 times 4. In the denominator, I'm multiplying 1 times 4 times y minus 6 minus y minus 3 over 4 times y minus 6 times 4 times y minus 6. That's canceling out those denominators. So all that's left is y minus 3. Now here's a place where you can trip up. So remember to write it in parentheses. It's better to just put every binomial in parentheses right away so that you don't miss that. Now I'll simplify. So 2 times 4 is 8 times y minus 6 minus 8. And on the bottom, I have 4 times y minus 6 minus y minus 3. I gotta keep simplifying. So 8 times y minus 6 is 8y minus 48 minus 8. And on the denominator, I have 4 times y minus 6, which was 4y minus 24, minus y minus 3 is minus y minus a minus 3 plus 3. The top is 8y minus 56, and the bottom is 3y, because 4y minus y, minus 21. Both of those expressions can be factored. I can factor an 8 out of the first one, and I get 8 times y minus 7. And I factor 3 out of the second one, and I get 3 times y minus 7. So the y minus 7's cancel, and this whole complex fraction simplifies to be 8 over 3. Wow.